Selection sort algorithm for Java arrays. In order to improve the speed in which our programs can search our data, we must first sort our data. The first sorting method we will examine is called the selection sort algorithm. So here we have an example of an array. These top numbers are the index values, and these are the values stored in the array. And using the selection sort algorithm, it keeps track of the current location for which we are trying to find the minimum value. Right now, we would like to find the minimum value in the array to store at index 0. So this red arrow simulates the selection sort method, traversing all of the other values in the array, looking for the minimum value. Now, by default, because the selection sort algorithm isn't going to access index that we are currently on, we set the current index to the minimum. So right now, the location of the array at index 0 holds 3. So right now, the minimum is set to 3. And as it traverses the array, it'll say, okay, at index 1 is 8. Is 8 less than 3? No, keep going until it finds something less than 3. You see we've moved on. We still have that the minimum is stored at index 0. It is searching each and every index, and it's comparing each value to the current minimum, which is 3. We get to index 3, it stores 7. That is still not less than 3. We get to index 4, which stores 2, and that is less than 3. So notice that the minimum is now holding the value at the array ARR at index 4. So currently this is the minimum. We are still have a current index of 0 because we would like to find the minimum and store it at location 0. And when we've reached the last element of the array, we see that the minimum changed yet again. So right now the minimum is set equal to 1. It is recording this index of 5, and it's going to do a swap between index 0 and index 5 so that we put the minimum in its proper place at index 0, but we don't want to lose the value stored there. So we'll place that at index 5 so we don't lose it as we continue to sort through each iteration. So we have a temp variable here. That temp variable is going to hold 3 in it. And then we're going to say our minimum is at index 5. So let's set the array ARR at index 0 equal to the value that is stored at index 5. And that means this 3 would disappear. Luckily, our temp variable is holding 3 in memory so that we could say now let the ARR at index 5 store 3 so we don't lose it as we continue to sort. Right now, ARR at index 0 is going to store 1, and that's the swap that occurs. This is for sorting, and this is to save our data. So we see that now the 1 is here and the 3 is here. Notice that this is shaded blue. That is no longer going to be in our for loop. Our for loop is going to be restricted to these values. This is the current index, index 1. So we're looking for the next minimum to store here. And again, we for now are going to set whatever is stored at index 1 as the minimum. So right now the minimum is equal to 8. But as we traverse the array, we will find new minimums to put in its place. Our outer loop is counting the index that we're currently trying to sort. Our inner loop is traversing the array in each iteration. So on our first iteration, we're going to say, is 5 less than 8? Yes, it is. So immediately the new minimum is set. The minimum is equal to 5, and the index 2 is recorded. So we'll say let j equal 2 as it's going through the inner loop. Is 7 less than 5? No, so it's not going to change what's stored in the minimum. The minimum is still holding the value at index 2. We found a new minimum. 2 is less than 5, so now the minimum is set to array at index 4. The minimum is equal to 2, and the index is going to be recorded, saying that that is the one we want to do the swap with if it is the minimum in this traversing of the array. And 3 is not less than 2, so still the minimum is at index 4. So minimum is still equal to 2, j is still equal to 4. This is going to be used in our swap. So you can see we're going to take the 2 and put it in this location. We don't want to lose our 8, so the temporary variable is going to hold 8 first. Then we're going to set ARR at index 1 equal to 2. And then we're going to say, well, where did that 2 come from? It came from index 4. So we're going to set ARR at index 4 equal to 8. So we don't lose our data, and that will become part of the sorting process in a later round. So we see the 2 is here and the 8 is here. The swap is done. These 2 in blue are done sorting. The outer loop has us on index 2. And the inner loop is going to go from 3 to 5. Again, the initial minimum is going to be the value at index 2. So right now the minimum is 5. And as it goes through the rest of the array values, it's going to be looking for a value less than 5 to set as the new minimum for this round. So 7 is not less than 5, it will just move on. 8 is not less than 5, it'll just move on. 3 is less than 5, and we are at the end of our array, so the minimum is going to be 3. The j value is 5. This is what we're going to use in our swap. So you can see the swap code over here. We're going to take temp, set it equal to the value at index 2. So temp is equal to 5, so we don't lose that data. Then we're going to change the value at index 2 to be equal to the value at index 5. So it's now going to hold 3. And then we say, let's use the location at index 5 and put our temp value in it so that we don't lose that data. So this will become 3. This will become 5. And we're ready for our next iteration. So now we see that our outer loop has the index equal to 3. The inner loop is going to traverse 4 and 5. Right now, our current minimum is 7, and it's going to compare it to 8, and then it'll compare it to 5. So 8 is not less than 7. The minimum stays at ARR3. The minimum stays equal to 7. But 5 is less than 7, so our minimum is now set equal to 5. And our index is equal to 5. This is going to be used for the swap. So here's our swap. You see that temp is now going to store 7. We are going to change the value at the index 3 to be equal to 5. And then we're going to say, let's put our temp value back at index 5 so we don't lose that data. So we expect 5 to be stored here, and 7 to be stored in the last box. And we're on our last iteration. 8 is the new minimum. It's going to look and see 7 is less than it. So it'll set the new minimum to 7 and the j value to 5. It'll do the swap. Oh, that's wrong. Temp is going to hold 8. ARR4 is going to hold 7. And then ARR5 is going to hold 8. That will complete the swap. And from here, we see that we have a sorted array. Now that the array is sorted, our next task is to write a Java source code that performs the selection sort algorithm on our arrays. So you want to write a method. And your method is going to have nested for loops. So your I value is going to start at I equals 0, and your j value is going to start at I plus 1. And that's so that each round, the search algorithm is going to be one ahead of the indexing algorithm. So let me back up for a moment here. So right after the swap, we see that I is going to be 3 for the search algorithm, but j is going to be 4 for the algorithm to go through all the rest of the values. So I is doing the indexing, j is searching everything. So that's why the j value has to be equal to I plus 1 on each iteration so that it's always ahead of the I value, and it can compare those to the current index. As we see 7, it'll compare 8 and 5 to it. So we have our for loop with the I, we have our for loop with the j. This is a nested for loop. And then in here, you'll have your if statements and your swap code. So try writing that out. I'll post the answer to the selection sort algorithm so you can compare your code to mine.